So this course is more about taking average as the central tendency than anything else. So that is the most common central tendency generally that we use. The other two are dispersion and shape. Dispersion I have talked about, but shape I have not talked about. Dispersion is all about how much it is distributed from the center. Three measures are available. One is range, the other one is IQR, another is the standard deviation. And standard deviation we have also discussed about the degrees of freedom, which is the most important in standard deviation. After the degrees of freedom is cleared out, we have two different formulae for standard deviation, one for the sample, another for the population. So population standard deviation is completely different from sample standard deviation, wherein the degrees of freedom in population is n and the degrees of freedom in sample is n minus 1. So is it clear till now? All this we have already covered, and I have also mentioned this Bessel's correction. This is something that is used, one second. So Bessel's correction is the one which is the proof for why there is a n minus 1 in the denominator. But I have just given you the formula, but not the proof. Will not discuss the proof part here because that is more of a theoretical concept, and that proof, even if I tell you, you'll not use it anywhere. So it's not a practical thing that you will learn. But wherever there is a proof that you require to use it, or at least to remember the formula, we'll discuss those proofs. But here Bessel's correction is not useful for your practical understanding, so that's why I'm not going in that direction. So that's about the standard deviation. And variance is nothing but it's simply the square of the standard deviation, which means the square root will get cancelled. All you get is this number, this formula, where it is sample standard deviation is sigma x minus x bar square by n minus 1, and population standard deviation is sigma x minus mu square by n. So this is what we discussed a day back, and then we started with covariance. The reason for introducing covariance here is variance and covariance, they have similar kind of formula, similar kind of properties. It's actually not it's actually not related to dispersion, but since variance and covariance has similar kind of structure or similar kind of formula, I tried to introduce it here itself. Okay. So the covariance is always about relationship between two variables. In case you want to find out any relationship between two variables, all you can do is you can do a scatter plot. Now, what is a scatter plot? It is a relationship between two variables in a graphical format. You just plot a graph, take one of the variable on x-axis, another variable on y-axis, and I already told you that you can interchange the x-axis and y-axis as you wish. It's always possible that in this case x-axis is its salary and y-axis is expense. It's always possible that I can use expense as the x-axis and salary as the y-axis. It's completely possible and it's valid. There is no hard and fast rule which one has to be x-axis or y-axis, whatever. So after plotting the scatter plot, we'll find out three different relationships. One is positive relationship, another is negative relationship, third one is no relationship. So all these three we can see based on the plot. So in positive relationship, the line, after you plot the scatter plot wherever the points are, if you connect all these points, the line that connects all these points will be increasing from origin to positive x-axis. You have to look in this direction. If you look in this direction, the height of this line, which passes through all these points of the scatter plot. By the way, scatter plot is only about the points. It's not about the line. Just to be very clear about this. The line I drew is only for your understanding. I just passed through all the points so that, if the line is in the increasing order, the height of the line is increasing as we go this side, then it is called positive relationship. Okay, in positive relationship, what happens is when one quantity or one variable increases, another variable also gets increased. So for example, in this case, as salary increases, expense will also increase. And that is obvious because the more you earn, the more purchasing capability you do have. It's called purchasing power. The purchasing power of your your purchasing power will get increased as your salary increases. So you in that case, expense will also increase. Of course, there are some people who even if their salary is increased, their expense will be at moderate level. But I'm not just talking about that. I'm just talking in general. Okay, and then negative relationship is the reverse of whatever we have seen here. Negative relationship is like as one variable increases, other variable will decrease. So in this case, I gave an example of years of service and resale value. It could be also, as Vijaya suggested, it is more like number of miles you travel versus or distance traveled versus the amount of fuel in your tank in your vehicle. So in both the cases, what happens, one variable when it is increasing, other variable is mandatory. It is mandatory that other variable will decrease. There is no other option in this case most of the times. And no relationship, it's more like these two variables are unrelated. So in which case, when one variable is changing, other variable will not change. So I gave an example where your monthly expenses versus monthly crimes in New Jersey. How would anyone relate your expense with New Jersey crimes? So the crime rate is not at all impacted by your expense. So in most of the cases, there is no relationship. So in that case, the graph that you see, you don't see a particular trend. You cannot say is it increasing or it decreasing or how is it happening. So I gave a real world patterns. Most of the times, you'll not see a single line. When you plot the data, whatever I have shown, this is not the real world case that you'll see. Not all the points will lie in the same straight line. It's more like if there is an increasing trend, it's more like you'll see like this. You'll see a band. You'll not see a straight line. You cannot pass a straight line through all these points. And that is what is the real world scenario. So in that case, how to identify if it is a positive relationship or negative relationship or no relationship? So the first one I gave is the band that is either parallel to x-axis or y-axis. Notice that I am just saying that the band itself is parallel to x-axis or y-axis. It's not it's not that I can pass through any straight line through all these points. I cannot do that. Okay. So in this case, there is no relationship. If the band itself is at an angle to x-axis, and especially it's not 90 degrees to x-axis, in which case this is no relationship, then it is called positive relationship. And if the band is again some angle, but there is a decreasing trend, then it is called negative relationship. So this is what we have discussed past few days. Any questions till now what I have discussed? I just wanted to give a briefing again.
I had some questions.
Sure,
I guess
sure.
I'm not confused. Give me 1 second. I wrote it down.
Sure, go on.
So we did that example about the height, I think again in the Excel,
Yes.
and we were finding the standard deviation for the sample and the population.
Yes.
So you mentioned that if we use the population data to find the, I guess, x minus mu, and the sum of that would equal to 0, correct?
Yes. If you take the sample data, you want me to show? Is that your question, or you still have something to tell?
Other question related to that.
Okay, yeah.
So basically, because both in, like you said, both in like real life and simulation, when we're trying to find the population standard deviation, x will be the sample data, correct? And if by any chance we have the population data, then we should use the population data to calculate the standard deviation.
Yes, exactly. You're right.
But then if we use the population data to calculate the standard deviation, then won't the sum of x minus mu equal to 0?
It will be. You're right, actually. But let me tell you something else, a little bit more background about it. So you're right. So if you are taking x minus mu, sigma x minus mu, where x is from the population data, then this is definitely going to be 0. Or let's actually do it. Let's take mu. Mu is nothing but average of, sorry, 1 second. Average of, I'm selecting all the data, which is Control Shift and down arrow. Remember this key combination very well. Control Shift and down arrow. Okay, this is my mu. And you want me to calculate x minus mu? Let me do that. X minus mu. And this is definitely going to be 0, mind you. X minus mu. And this mu, I wanted to keep it as a constant across all the cells. Okay, I kept it as a constant by giving a dollar. Now, there is a shortcut here. Which if I, okay, it's not coming. That's fine. Actually, I should not drag it. If I click it there, it should populate all the values. Somehow it's not working on my system. Okay, I need only 10,000 of them. Let me take only 10,000. Okay, I need until here. So from here to the end, I'm going to remove it. Okay, now I want to do sum of all this. Sigma of x minus mu, which is nothing but sum of all these elements, right? So let me do sum from here to the end, and this is going to be 0, 10 power minus 9, very much closer to 0. So like I said, whenever you do sigma x minus mu, it is going to be 0. Now the question is, why should it be n? Why should it not be n minus 1? So statisticians, what they have found is, there are two reasons why they mentioned this should be n, not n minus 1. The first reason is, when x is from sample, there is no reason why it should be 0. So in that case, the degrees of freedom will be n minus 1. Sorry, degrees of freedom will be n. So that is one reason. In this case, what happened? Degrees of freedom is equal to n. Now there is another case where x minus mu is equal to 0, where x is from population. So in this case, the degrees of freedom is n minus 1, but the problem here is, sigma x minus mu by some 10,000 versus sigma x minus mu square, sigma x minus mu square by some 9,999. So the value that you get out of this minus 1 is very much negligible. But what is the problem in this case? So in sample, normally you'll take maybe a 30 sample or 10 sample. So this kind of samples you take. So when the sample size is very less, n minus 1 is going to play a bigger role. So there is a larger difference between sigma x minus x bar square by 9 versus sigma x minus x bar square by 10. There will be larger difference compared to this. So in population, in any case, this n minus 1 is not going to be useful. That's what the statisticians found out at last. So what they did is they combined both of these into single formula for population. And in any case, when there is a n minus 1 in the denominator in sample standard deviation, there is a correction that is going to happen, and that correction is going to be useful in sample. So these are the reasons why they came up with a single formula here in population. Does this answer you, Vijay?
Yeah, it answers. So then again, if by any chance we have the population data and we use X as the population data, then again, the answer is almost close to 0. So then how would the answer make any sense? Or
answer is not 0. Why is the answer 0? Answer is 0 when it is sigma x minus mu. Answer is non-zero when it is sigma x minus mu square.
Oh, okay. Yeah, makes sense then. Okay.
Right?
Yeah.
I can do that maybe. What is that? Standard deviation. I'm just giving it as STD, standard deviation. Standard deviation population. Let's do both of them. Let's see how much difference we'll get. I'm taking from the first to the end. I have never done this. Standard deviation sample. Okay. How much are you getting? Is it almost the same? Very close until 2 digits? I mean 2 decimal points.
Yeah, very close.
So that's what I mean. But if you take a sample of, let's say, 10, let's take 10. Generally sample is supposed to be small, right? The correction is going to be bigger. And it's understandable. I think by now you might have got some intuition. Is it bigger difference?
Yeah, kind of, yeah.
Yeah. So that's what is the intention of n in the denominator here. Okay. So in population, you can see standard deviation population versus sample. There is not much difference. There is a 0.001 difference, I think. Not even that, I think. Yeah, 0.001, which is 1 by 10, 1 by 1000, 1 by 1000, yeah. And here there is a lot of difference comparatively. You can see this one minus this one. There is a 0.45 difference. And as the population size increases, you can see 0.009, which is close to 0.001. Okay, as the population size increases, actually 10,000 is not even close to population size in general. No, you may have 100,000 at minimum, or even some millions. So whatever I'm showing here is also not really the population data. Maybe it is 1/10 of what the real size of the population is. In that cases, this difference will be much lesser, and there is no reason why we should not use population standard deviation or sample standard deviation in this case. Both makes same sense in this population population formula. But in sample formula, this is having a much bigger difference. Hope this clears, Vidya.
Yeah, it does. Thank you.
Yeah.
Sandeep, can you go back to Excel once?
Okay. 1 second. Yeah. Okay.
Yeah. My doubt is this standard deviation, we are getting the value 19.89 something. What is this value represents here? 19.89?
Okay, it is the average deviation from the center. When I say center, it is central tendency.
Okay.
So what we are doing, let's see the population standard deviation and understand. X is your data, or let's do one thing. Let's do standard deviation formula from here itself. But before doing, let me explain what is happening. So X is what? X is your data point. Actually,
Yes.
how it should be? It should be sigma xi minus mu, where I runs from 1 to n, and this is a square on this, by n. This is the real formula that I should apply, but I am just writing as sigma. Actually, I am discarding all these i's. Now, what
Yeah.
does it I means? I means every data point you have to subtract from the mu.
Yeah.
Subtract every data point from the mu. Then you'll got here. But what I am supposed to do is, I am supposed to square each of them, then take an average. What does it mean? It is the average deviation from the center. Center is my central tendency, which is mean here.
Okay.
Like I said, most of the times we'll take only the central tendency as mean, not median. I just told you, right?
Yes.
When I was recapping. So in most of the cases, what you do is your central tendency is most of the times you will be representing it as in itself. Generally, very rarely, actually, your central tendency will be mode. You can take it. It's not bad that you have to take median, but for median the mathematics will be much more involved than mean. That's why generally we'll take mean. Okay. Now what I'm taking, for every data point, I'm trying to find out the distance from the mean
Center.
center.
Yeah, mean.
I'm taking a distance from the center. I am taking a sum of all the distances. What does it mean? How much deviation it is from each point. I am summing up all of them, then taking an average. It is an average deviation from the center. But unfortunately, what happened? If I don't take this square, everything is becoming 0. That's why I'm taking the square. Now to offset the square, what I am doing? That average squared deviation, I am taking a square root, which means it is an average deviation from the center. That's it.
Okay.
Are you getting what I'm saying?
Oh, yes, Sandeep. Yeah, got it.
Okay. You want me to do it on Excel, or shall we leave it there?
Not good. Got it.
You got it, right?
Yeah.
Okay. Any other questions?
No questions.
Okay, cool. Let me remove all these things because you already have whatever you want here itself. Okay. Now, so we have variance and covariance. Now, covariance is representing how much, how closely that two variables are related. But all we can find out in scatter plot is only, is it a positive relationship, or is it a negative relationship, or is it a no relationship? In all these scatter plots, one thing that we are missing is how closely the variables are related. It's just showing there is a relationship, but it's not showing how closely they are related. And that is where we have something called covariance. Okay. Concept is covariance, and it is represented by sigma. Sorry, something wrong. Yeah, it's represented by sigma. Now what is covariance? Covariance is kind of a metric. It's more like your variance kind of a metric, which will show the strength of the relationship. Or let me define it as, it is a metric to find out the relationship between two variables. It's more like the same scatter plot, but instead of plotting something, it will give you some number. And what is the formula for covariance? Covariance is given by sigma is given by a simple formula. It is nothing but sxy by n minus 1. Now what is sxy? Sxy is nothing but sigma x minus x bar into y minus y bar. So where x and y are the variables. So you have two variables. Each variable will have x bar. So x will have x bar as its center or average, and y variable will have y bar as its average. So depending on both the averages, you are just doing a sigma x minus x bar into y minus y bar. Okay, is that clear till now?
Yes, Sandeep.
Okay, now what happens when actually this should be given as covariance of x comma y. Now what happens when x and y are same? Covariance of x comma x. What happens? It will become sxx. So based on this formula, let me substitute here also. Sigma x minus x bar into y minus y bar by n minus 1. This is your formula for covariance. Now what happens when x and y are same? What I mean is covariance of x comma x, which becomes sxx by n minus 1, which is nothing but sigma x minus x bar into again x minus x bar, which is nothing but sigma x minus x bar square, right? And you already know this formula. This is nothing but variance of x. Is that clear? So covariance of x comma x is nothing but variance of x, and covariance of y comma y is nothing but variance of y. So covariance is a modified version of your variance formula. That's why I said there is a closer relationship between variance and covariance. Now you got what is covariance. I have just explained, but there is a problem with this covariance. Before going into the problem, why covariance is not very much useful, we'll just go through some exercise for finding out this variance in Excel. Now I have already shared you the notes and the data sets itself.
For covariance, is there a different formula for sample and population?
Okay, so in general, no, because you'll generally do not know the entire data set for a variable, entire set of values for a variable. So in general, covariance, there is no different formula. The reason for having population variance is because for many of the theories, you need a theoretical formula. Even in population variance, what I mean is, even in population variance, you'll not use this formula much often. This is useful only for the theoretical concepts, not for the practical application. Remember this. So similarly, even if you want to do it for population, let's say you have all the data for population, you already know the concept. For population, you can directly straightforwardly, you can use n, not n minus 1, right? So for covariance, if you want a population covariance, just go for n. You don't have to worry about what I mean. In fact, in Excel, I believe there is a population covariance formula. Yeah, you can see here, sample and population. What does it mean by population? Again, the same thing, whatever I described. It should be n. The degrees of freedom is n there. But most of the times, the population standard deviation and population variance is most of the times used for theoretical concepts. If you want to derive any formula, so those kind of scenarios, you need to use this population standard deviation formula. Is that clear?
Yeah.
You'll regularly use the sample one. But if you need to derive anything, or if you want to find out some mathematical properties, then population standard deviation is the one to go. Now let's go to Excel. So I have already shared you this directory. Let me know, just check, and if you did not get, let me know. I'll share it again. Okay. Now we need to see something. Okay, I did not share this. One second. Correlation. Yeah, I should share this. Check your mail. If you did not get yet, then please let me know. And one more thing, do not change anything on the drive itself. If you want to do any Excel calculation, download that file and do it at your local. That is something that I wanted to mention you. Okay, so I just wanted to calculate this covariance using Excel itself. Okay, is that Zahir? Zahir, are you there?
Yeah, Sandeep, I'm here.
Hey Zahir, I thought you'll be joining today, but I did not see you.
Yeah, mistakenly I thought 8:30. So, but yeah, please continue.
Okay, okay. Okay, thank you. I'll include.
Thank you, Sandeep.
Okay, I'm just removing all these things so that we'll be able to calculate all this together now. Now this Excel sheet is having age and weight. I have already described this two things, and I have already shown you how to do a scatter plot on this. But now we wanted to do some, we wanted to get some metric. We want to know how much it is, how much is the relationship. So for that, so what I was describing now is the covariance. We want to see if the covariance solves our problem or not. So what I'm doing here is I'm calculating the covariance using the formula that I just described, Sxy by n minus 1. Okay, now let's see how it goes. First thing is calculating x bar. In this case, I am considering age as x and weight as y. What I am doing is I am calculating x bar, y bar, which are these two quantities here, x bar and y bar. And then I am trying to calculate a difference, which is x minus x bar and y minus y bar, which will be these two quantities. And then I need to multiply these two, which is this one, this column. And there are two more columns, which is x minus x bar square and y minus y bar square. This is used for variance of x and variance of y. For now, let's not consider these two. Let's consider only these 5 columns. Let's see how it goes. Now, x bar is nothing but average, and for average, I can do the first one and command shift and down arrow. This should do. X bar I got. And what I am doing is, for simplicity, instead of doing like this, for simplicity, I'm copying this same cell across all the data. Okay, this will help me in simplifying. I don't know how many data points are there. Is it 1000? Yeah, 500, I think. Okay, 500. All the data points I'm copying the same average. For calculation simplicity, I can do without also. Again, I'm doing y bar, which is average of weight. I'm taking all of this. I'm keeping a dollar here to make it constant. And again, I'm copying all these things. Okay, now I'm getting it. If I click at the edge, it should copy all the data to all the cells. I mean, copy the formula to all the cells. Now I can do x minus x bar. This is x and x bar is here. Again, I can do a copy of all these cells. Okay, I have done x minus x bar for all the cells. Now I'm doing y minus y bar in this column. Y is here. Y bar is here. Okay, it is copied. Now what I have done till now is I calculated this quantity x minus x bar, and I have calculated this quantity as well, y minus y bar. Now I have got two columns where which I need to multiply, because all I need is x minus x bar into y minus y bar. Let's multiply x minus x bar into y minus y bar, and again I have to copy these cells. Okay, now what I have done is this x minus x bar into y minus y bar, but how many such quantities I'll have? I will have n different quantities for x minus x bar into y minus y bar. I have to sum all of these up. When I have a sigma here, all it means is, it means that sigma x minus x bar into y minus y bar, actually it means that I runs from 1 to n xi minus x bar and yi minus y bar, which means I have n such quantities. I have to add up all of them. So let me do it here. Sigma or covariance numerator, I'll say. This is much easier for me. What is the covariance numerator? Which is nothing but sigma x minus x bar into y minus y bar. Let's do it. Sum of all these quantities in this column. Control shift and down arrow. Okay. I got some minus 37 as my numerator. And what happens with the denominator? Denominator is fixed. I have 500 data points. I should use 500 here. Now what is covariance? Covariance is nothing but, sorry, denominator is, let me keep n here. N is 500. Denominator will be n minus 1. This one minus 1. Now what is my covariance? Covariance is nothing but this one by this one. Numerator by denominator. I get some covariance, and it is saying that it is having some negative relationship. It is saying minus 0.07. Let's go back to our scatter plot again. I know you remember it, but I wanted to show it again. Our scatter plot, sorry, this is not scatter plot. Our scatter plot is not showing any sign of negative relationship, right? It may be, it is a little bit down here. I don't know. I can probably draw a line, because in this kind of lines, I can draw a line in any direction. Most of the people may be drawing like this. Maybe there is a line like this, I don't know. That could be the reason why there is a negative relationship that it is showing. Okay, but you can see that it is very little, the value is very small, 0.0 minus 0.07. So that could be reasonable because it is very small, so maybe in the scatter plot we are not able to identify. Is that clear till now, whatever calculations that I have done?
Yes.
Okay. Okay then. Now, based on this, we have identified the covariance formula, and we have also tried to find out what is covariance between these two quantities, which is age and weight in this case. But what happens when so in this case, age is in years. So 34 years, 40 years, 34 years. So every quantity that you have seen, that you can see here in this age column, all these represent only one unit, and that unit is nothing but age in years. What happens when the age is in days or months? Let's take months for example. What happens when someone represented this age in months? Will the covariance be same or will the covariance differ? This is the question that I have in my mind, and I'll try to answer that by simulating this again. Is that clear? Are you clear till now what I just mentioned?
Yes.
Okay, before that, let's see Excel covariance. What does it mean is, I'm just trying to use covariance formula of Excel. Covariance of S, which is nothing but the first variable you give it as an array, and then comma. You again select the second variable as an array. Okay, when you give this, you should see the same covariance. Okay, it means that we are doing correct. Now, and you can also see the population covariance. Covariance P, or let me do one thing. Let me copy the same formula. Okay, copied the same formula. I'm just changing the S to P. Are you seeing much difference? It's not much again. Okay, when the data size is in general, there is a rule that anything more than 50 or 60, the population variance and sample variance will be same. Same case with covariance. When the number of data points is around 50, you can use any. Okay, that is more like an empirical rule than a standardized rule. You may come up with your own standardized rule, I don't know. Okay, now based on whatever I have done till now, can I try to make some changes to the existing data, and then will I find the same covariance or different covariance? What I mean is covariance independent of the units of the data, or is covariance dependent on the units of the data? This is what I wanted to find out. Okay, let's see. In this case, like I mentioned, this age is in years. If I make it into months, is the covariance value changing or not? Only then, the reason for doing this is I started with scatter plots, and in scatter plots I could not find out the strength of the relationship. I could only see that there is a trend of upward, there is an upward trend or downward trend, but I could not really make out how much is the strength of that relationship between those two variables. Now, what I wanted to do now is, I want to see, I got some covariance value, is that value real value, or is that value changing with the units? If I change my units of the data, is the covariance value changing or not? Let me find out that. Let's see how to do that. Now what I am doing is, instead of this age, I am converting this age into months, which means for each of these value, I am multiplying by 12 months. So for example, 34 years means 408 months. Similarly, I do for all of these data. Okay. I don't know, sometimes it is not working. Okay, that's okay. I'll just drag it.
Maybe you need to keep dollar signs in the expression.
No need. The reason is, so why dollar? The reason I generally use dollar is, if I have to use the same value in all the fields, I'll use a dollar. But in this case, what happened? This is A2 into 12. And in this case, it is A3 into 12, which is this value into 12. But in case, what happens? Let's see what happens if I use a dollar. If I use a dollar here, what happens is, if I drag it on, this is A2 into 12. This is also A2 into 12. This is also A2 into 12. It will use the same field for all the calculations. So which is not what I want, right? I want to multiply each value into 12, not only the first cell.
Okay.
So that is the reason why I use dollar. By the way, if I seem to go faster in Excel, let me know. Because my assumption is Excel is kind of very easy. Even if you don't know, you can see and learn very quickly. Okay, the last one is not useful. So I have used it for all the 500 rows for age. Now what happens with weight? Weight is same as what I have here, right? I'm not changing weight for now. I can choose to change weight also, but it's not useful for now. That's okay. Let me keep the same weight here. Okay. Now I'm not doing all these calculations here. X bar, X minus X bar, all these things. I just showed you for you to understand what happens within the formula. For now, what I'm doing is I'm using covariance formula of Excel. Covariance of sample, and I'm using these two fields instead of those two fields. Okay, remember that I changed the years into months. 1 second, I should not do that. This value minus, and I have to use the second field, which is weight. Okay, I get some other different value. Okay, now what happens if instead of age is in months, let's say I multiply it by, instead of 12, I multiply it by 365, which is days. Age in days. What happens? Again, let's see. Sometimes it is working, sometimes it is not. Okay. Now, age in days. Now again, I am getting some other different value. Okay, earlier I got 0.8 or something before doing 1 second. Yeah, 0.89. When I did into 365, instead of when I used days instead of months, I got minus 27. But you can see, notice that in all these cases, let's see, covariance 1 is nothing but minus 0.07. 1 is nothing but in age in days. Sorry, age in years. When you use age in years, you're getting covariance as minus 0.07. Covariance 2 is age in months, which we are getting as minus 0.89 something. And covariance 3 when age in days. And this is the latest one, whatever you see here, which is minus 27.28. So what are you seeing here? What is the pattern that you see here? The pattern is here, in all these cases, covariance is having the same sign. The sign is not changing. Even though the value is changing, the sign is not changing. So in covariance, all you can use is the sign. The value is useless for you. What does the sign say? Covariance is 0. Covariance is equal to 0 when the data is having perfectly no relationship. When there is no relationship at all, covariance is 0. And covariance is negative when there is a negative relationship. And covariance is positive when there is a positive relationship. But still, you cannot take away with this entire session. The only thing you cannot take away is covariance will not show the strength of the relationship. Is that clear till now, whatever I mentioned?
Sandeep, here strength means either it is positive or negative only, na? Or how much positive, how much negative means
Yes,
strength.
that's what I meant by how much is the strength. So I can say that salary and expense are related using this graph. But can you say with some confidence or with some measure saying that this is my strength of the relationship?
Strength means basically how much it will increase. If suppose
Yes.
X is in, how
Yes,
much
for
it is
example, when salary is increasing, will expense increase increase at that proportion of salary increase, or it is less than the proportion or greater than that proportion? How do you know? What is the proportion of increase of expense depending on the salary increase? Your salary increased by 20%. Is your expense increasing by 10% or 5% or 1%? That is the strength. Are you clear?
Yes, Sandeep.
Strength shows you how closely they are related. You are saying they are related, but how closely?
Okay. Coming to the previous example,
Hmm.
so, means suppose age is increasing, how weight is increasing by using, suppose
Weight
if
is
you consider
decreasing. Weight is decreasing, right? This is a negative relationship. When
negative.
age is increasing, weight is decreasing.
Okay.
There is a negative relationship here.
Okay.
Okay.
Yes, Sandeep.
So the takeaway here is, okay, today I cannot give you a break. Is that fine? Because it's already past 7:30.
Yeah, I'm okay with it.
Okay. I'll try to make sure you'll get a break daily, but sometimes you'll have to bear with me. Okay. Now, what are the takeaways with covariance? Let me give it as a properties of covariance. The first thing is it shows the Direction of relationship. What does it mean? Covariance is less than 0. What it means is negative. Covariance is less than 0 if negative relationship. Covariance is greater than 0 if positive relationship. And it is equal to 0 if no relationship. Okay, this is the key takeaway. And second thing is, it is not, when I say it means that it is covariance. Okay, it is not independent of units, or in a way I can say it is dependent on units. Since it is not it is not independent of units, you cannot take the value as a absolute value. This value keeps on changing based on the units that you took the measure for. So what you can do, the value doesn't make sense. Why the value doesn't make sense? Because it keeps on changing based on the units. Only sign should be taken, should be interpreted. Only sign should be interpreted. In covariance, never interpret the value, because it is very dangerous. If you interpret the value, you are gone. You are doing some mistake. Okay, this is all about covariance. Are you clear with this concept? How is it independent of the unit? I mean, not independent of the units and all. Any measure that you take should always have a single value. If the value is changing, then the value doesn't make any sense. That's what I mean by value doesn't make sense. Okay. Any questions? And the final one I can write. Covariance of x comma x is nothing but variance of x. Covariance of y comma y is similarly variance of y. Okay. So this is all about covariance. Like I said, again, we started with representing relationship between two variables. Scatter plot looks good, but it is not giving you a measure. How much is a positive relationship or how much is a negative relationship, it is not giving. Now similarly, we have a negative relationship, same case, and no relationship also. There is no way that I can give a single value for how much is the relationship. Then we tried to find out covariance. Again, we got the same problem. Actually, if you see, there is no difference between what your scatter plot is giving versus your covariance is giving. But the only thing is, when there is a relationship like this, let me show it again. In your scatter plot, you have seen there is a no. I think I messed up with something. 1 second. Okay, I'm not using the proper one. Okay, if I do a scatter plot, your scatter plot is actually giving no relationship, but your covariance could identify that there is some negative relationship. Okay, so sometimes interpretability is very difficult in scatter plot, it's kind of much easier in in covariance, because covariance is giving you some specific value. Either it is a negative or positive, I don't care, but it is specifically saying it is negative or it is positive. But in scatter plot, you have to interpret yourself. Sometimes it is very hard to interpret these scatter plots. Sometimes it is easy, but sometimes, most of the times, when the data points are too large, your scatter plot is very difficult to interpret. So in that sense, I would say covariance is much better metric than scatter plot, unless you want to show it to some manager or someone who doesn't understand covariance. Okay. Now, still you are faced with one problem. The problem is the value doesn't make sense, which means that you cannot interpret the covariance using how much is the relationship between those two. You can only say it is a negative, positive, or no relation. Now, how to do the other thing, and that is called correlation. This metric is called correlation, and correlation is represented by rho. Okay, it's more like P, more or less like P, but this is called rho. And what is the, how to find out the formula for, what is the formula for correlation? It is given by this formula, which is Sxy by square root of Sxx into square root of Syy. And let's say if you divide the numerator and denominator by n minus 1, what happens? Let's see. It will become Sxy by n minus 1, and this entire denominator by n minus 1. This is how it will be. Now, Sxy by n minus 1, you already know the formula about it. It is nothing but covariance of x comma y. Just now we discussed Sxy by n minus 1. And this n minus 1, I can take it inside the square roots. Let's see how it becomes. It becomes Sxx by, square root of Sxx by n minus 1 into square root of, one second, square root of Sxx by n minus 1 and square root of Syy by n minus 1. Any thoughts about what is inside this? Sxx by n minus 1. It is nothing but variance of x, right? Covariance of x comma y by square root of variance of x into square root of variance of y. So you have two formulas ultimately. The first formula is covariance of correlation of x comma y can be written as Sxy by square root of Sxx into Syy. That is nothing but covariance of x comma y by square root of variance of x into square root of variance of y. You need to remember these two formulas always. Okay. In general, I'll keep an R so that you'll remember that you need to remember this. Any formula that you need to remember, I'll keep R just by heart this formula. Okay. Any questions till now? I just derived a few things here. It's a very simple derivation. I mean, it's nothing. It's not even called as a derivation actually.
So isn't the square root of variance x is standard deviation?
Yes, yes, you can write that way also. You want me to write? Okay, I can write. You can take that way also. I just wanted to keep everything in covariance and variance terminology, but that's fine. Standard deviation of x into standard deviation of y. Actually, I should keep, instead of keeping like this, I should keep it in this format. Sigma x, sigma y. This is the right terminology. Okay. Any questions still now? Sigma is nothing but the standard deviation, and sigma square is variance. Any questions still now?
So sigma is population. So
You can use S. Yeah, you're right. You're right. You're right. It's my mistake. You're right. My mistake. It is Sx into Sy.
So there won't be any such thing as population in correlation as well.
Again, yes, actually it is. You're right. But the reason for that is, you know, the n minus 1 on the numerator and denominator will get cancelled, right?
Yeah.
So in this case, if you use population, what happens? This is n here and n here. If you use sample, it is going to be n minus 1 here and n minus 1 here. In either case, either it is a population or is it a sample. There is no reason why you should have a different formula for population. In this case, for correlation at least. Got it?
Yeah.
Both are same here. I think in Excel you will not find a formula for population if I am not wrong. Okay. Correlation. Okay, you are seeing only one formula. There is no dot S and dot P. Why is that? The reason is because this n minus 1 gets cancelled. There is no difference in this case. Is that clear or you are confused still?
No, it makes sense.
Okay, cool. Okay, now how to do the correlation? Again, the same steps, but in this case, again, I am using the Excel formula directly. Correlation, sorry. Correlation. The first variable, comma, the second variable. I took the age in years here. Let me keep that. Age in years. Let's try the other one also. Age in this case, it is age in days, I think. Correlation of all this, the first variable, comma. I think Subbu, can you keep on mute? I am getting some echo back. Okay. The first variable and comma second variable. Both are same. Okay. So correlation is mostly preferred way to do any relation between two variables, because you already saw this, whether it is age in years or age in days, it doesn't make any difference for correlation, but covariance, it is always changing based on the units. Okay, that's why it is always preferable to use correlation rather than covariance. But there are some cases why we use covariance. So the covariance is generally used because of its mathematical properties, not because of its the value that it produces. Most of the times whenever we use covariance, it is only for some theoretical purposes, and correlation is for your practical understanding. So that's why it is always there is a reason why I teach covariance, and you'll see covariance in many theoretical applications. And anytime you need any practical solution for any relationship between two variables, you go for correlation. Is that clear? When I say theoretical purposes, it means that if you want to derive anything or find out any formula or anything, use covariance. But if someone asks what is the relation between these two variables, use correlation. Any questions?
Yeah, so in this example, the correlation was negative 0.002. So from correlation, can we conclude that it is a negative relationship, or we cannot?
We can, but
Okay.
in correlation, the value is absolute, right? The value doesn't change. It's the value is really representing the data. Now, what is the value here? How much is a relationship? What is the strength of the relationship here?
It's very less, 0.003.
Yes, that is the reason why you are seeing this kind of graph. It's almost parallel to the x-axis. What did I say? When the data is either one second, sorry. When the data is either parallel to the x-axis or parallel to the y-axis, then there is no relationship. That's what I can see here. But in the correlation value, it is showing very, very less correlation, right? It means that there is some negative correlation, but it is negligible. Can I say that?
Yeah.
It is very less. That's why you cannot see in your graph also. Okay. Actually, there is a reason why I use this kind of relationship. I could use a positive or negative relationship, but in which case I cannot show this kind of relationship, this kind of thing.
And I guess how would you interpret the result?
The result, in this case, I would interpret this as a no relationship than a negative relationship. The reason is the strength is very less. It's not having any strength in the negative relationship, right?
So when would one consider it having a relationship, when the number is greater than 1, or?
Yeah, I'm going to that.
Okay.
Okay, I'll go to that. But you are clear until here, right? How to interpret this part?
Yes.
In this case, I would interpret this as a not having any relationship because it is very close to 0. In reality, you'll not have 0 actually. In reality, you'll not have a perfect 0. All you'll have is a number like this. If it is very close to 0, just interpret as a 0. Do not expect, remember this point, do not expect a perfect 0 in this case. You'll never have, in reality, you'll never have a perfect 0. You'll have either a small positive number or very small negative number. In both the cases, assume that it is 0. And the second case is, do not always interpret only this number. Take both of these into consideration, both the scatter plot, both this, I'm not sure. Yeah. both this scatter plot as well as this number. Take them together and consider for analysis. Why? Because you don't know, do you have to take 0.002 as 0, or should you take 0.002 as 0? Which one should you take? You don't know, right? Are you clear or not? How much is closer to 0? Is this closer to 0 or this closer to 0? I don't know. Actually speaking, if you compare these two, this is much closer to 0. But if you are given only one number, can you say it is closer to 0 or not? Most of the times, you'll get confused. Is it 0 or not? No relationship is much harder to explain than any other relationship. Are you clear so far? Why no relationship is harder to interpret? In this case, I don't know if it is closer to 0 or not. How much is closer to 0? I don't know. Maybe someone might consider this as not closer to 0. Someone else might consider it as closer to 0. It depends on how we interpret this number. So the better way is take both the scatter plot as well as your correlation value. Depending on both of these, interpret the results. In this case, my correlation scatter plot is almost parallel to x-axis, and the same thing I am observing here in the correlation. In this case, I interpret it as a 0. Are you clear so far? Any questions? Any confusions?
So basically, to determine if it is a no relationship, just look at the scatter plot and the correlation number.
Yes, look at both of them together. Only then decide.
Oh yeah, so only then we can decide if it is closer to 0 or not.
Exactly, yeah.
Okay.
And this is the reason why many people try to automate this entire data science but never could do it. There is some human intelligence always that is required in all the things, not just correlation. Correlation is one of the basic things that you learned, and even in that you need your human intelligence, right? Your computer cannot say is it parallel to x-axis or not, scatter plot. Is that clear? Any questions?
Fine, Sandeep.
Cool. Okay, let me write the properties of correlation as well, and then we'll close the session. I already explained what are the properties, but just I wanted to know what are the properties. The first thing is it talks about both direction as well as the strength of the relationship. So we are talking about both the strength and the direction of the relationship, not just the direction, not just the strength. And this question Vijay asked, and I'm going to answer here. Correlation is rho, right? Rho is always between -1 and +1. What does it mean? It means that rho is less than or equal to 1, -1. Sorry, greater than or equal to -1 and less than or equal to +1. That's what it means by writing this. If you want, I can write it separately. This implies rho is greater than or equal to 1, -1, and rho is less than or equal to 1. So your row always lies in between -1 and +1. If your correlation is exactly 1, what does it mean? It's a perfect correlation between those two variables, perfect positive correlation. When the row is -1, it means that it is a perfect negative relationship. Is that clear?
One doubt. When rho is equal to -1, exactly, perfect no relation. It means that there is
no, perfect negative relationship.
okay, perfect negative.
Let me write that. Rho greater than 0. It means positive relationship. Okay. Rho less than 0. Negative relationship. The question is, will you ever get rho equal to 0? May not be. Most probably, I have never seen 0. Perfect 0, I cannot see. I won't see. So I will say, instead of writing rho equal to 0, the better way is rho is approximately equal to 0. What happens? No relationship. Based on this, it's up to you to interpret. I cannot say is 0.1 if you get correlation equal to 0.1. Can I say is it a positive relationship? May not be. It may be 0. I mean, it may be no relationship also. But in general, 0.1 kind of cases, it is a positive relationship. But what if it is a 0.001? I can still say it is a positive relationship, but the better way to interpret is it is closer to no relationship. There is not much relationship between those two variables. That's what I can interpret in this case. Okay, but like I said, always look at the scatter plot as well as this value. Then take a decision based on both of them together. Okay.
If I had a number of 0.5 or 0.7,
then it is definitely a positive relationship.
Okay.
Okay, anything less than this number or anything less than this number, interpret as no relationship.
Okay.
But this is more like a rule of thumb that I am giving. Okay, I think that part I made it clear. I cannot say in some cases even this is positive relationship. I don't know. Always go to your scatter plot and this number, then interpret. And it's okay you take wrong decision. Sometimes in data science, every decision that you take is going to carry with it some risk. Every decision is going to have some risk. Whether you say it is a no relationship or it is a positive relationship, in that case, both the decisions are going to be carrying some risk. What you have to take care is, wherever the risk is less, you take that decision. But in any case, there will be some risk. It's more like there is a big line and small line. You take the small line as the smaller one, but it doesn't mean that this line doesn't exist. There is some line, right? Similarly, here also, there is always a risk. Whichever decision you take, there is a risk. All you try to do is that you take a decision which has a minimum risk. There is no zero risk, at least. Now, what happens when there is a correlation of x comma x? And it's not, 1 second. Correlation of x comma x and correlation of y comma y. Any ideas or thoughts? Okay, this is an exercise for you. Try to find out correlation between the same variable, x comma x or y comma y, whatever it is, and let me know the answer tomorrow. Is that fine? I have shown you how to do all these Excel calculations, everything. You can use this same Excel sheet to find out this. Is that fine, Zahir, Subbu, and Vijay?
Yeah, sounds good.
Fine, Sandeep. Can you upload this Excel sheet also into the drive?
I think this is already there. Is it not there? This is uploaded.
Okay, okay. Sure.
Okay, this is uploaded.
When did you send the email for the links for the?
Yesterday I have sent. If you can you check your mail right now?
Yeah, I didn't get any.
Okay, I'll forward again.
Okay, thank you.
Okay.
Sandeep, what was the question you asked?
I just wanted you to do this correlation of x comma x and correlation of y comma y. I
Yeah,
mean,
okay.
if you do one, the other one, the value will be same.
Yeah.
Okay.
Okay.
I just wanted the answer for that. Okay, Vijay, you did not get, right?
Yeah, I did not receive it.
Okay, fine. I'll send you again. Any other questions before we close?
No.
Zahir, by the way, the class is at 8 p.m. I believe. Is it 8 p.m. Vijay for you?
Yes, Eastern time. Yeah.
Yeah, 8 p.m. Eastern time.
Yeah, I missed it. Yeah, it was on the impression it was 8:30. I just checked my notes. It was 8 o'clock. It was my mistake.
Okay, okay. I thought I made a mistake. Okay.
No.
Okay then.
Okay. Thanks.
Okay,
Sandeep.
thank you. Thanks everyone. We'll catch up tomorrow.
Okay, Sandeep. Bye.
Bye.